Android has long relied on a 4 KB memory page size, a detail so consistent that most developers never gave it a second thought. But with the release of Android 15, Google is shaking things up by introducing support for 16 KB memory pages. This isn't just a minor technical tweak, it's a change that will impact how apps are built, tested, and even whether they're allowed on the Play Store. In this video, we'll break down what this shift means for developers and users, and why acting now is crucial for anyone building Android apps. Start with the basics. What exactly is a memory page? Think of your app's memory as a massive spreadsheet. Instead of tracking every single cell, the operating system groups them into blocks. These are the pages. The OS then keeps a ledger of which block maps to which physical location in memory. For decades, 4 KB has been the standard page size in Linux-based systems, including Android. This balance made memory management efficient and straightforward. But as hardware evolves, so do the possibilities for optimization. Why is Google making this change now? The answer lies in performance. Google's internal benchmarks showed that moving to 16 KB pages brought real improvements. Apps launch about 3% faster on average, with some cases seeing up to 30% gains. Camera startup times improved, system boot was nearly a second quicker, and battery life saw a 5% reduction in power draw during app launches. These numbers might seem small, but across billions of devices, they add up to a noticeably smoother experience. Support for both 4 KB and 16 KB page sizes exists in Android 15, but Google's direction is clear. Starting November 1, 2025, every app or game update targeting Android 15 or higher must prove compatibility with 16 KB pages to be published on Google Play. This isn't just a suggestion, it's a requirement. If your app assumes a 4 KB page size and you don't adapt, your updates could be blocked from release. That makes this change not just about optimization, but about compliance. If you're developing entirely in Java or Kotlin, you're in luck. The Android runtime handles memory management for you, so you're mostly unaffected. But if your project uses native code like the Android NDK, or relies on high-performance libraries, game engines, or specialized SDKs, you need to pay attention. These systems often interact directly with memory and file alignment. If they assume a 4 KB page size, they'll fail on devices using 16 KB pages. This is especially important for developers working with C, C++, or custom binaries. Good news is that modern versions of the Android NDK already support 16 KB page sizes. If you're using NDK R28 or higher, your builds are aligned correctly by default. But if you're on an older version, you may need to add specific linker flags to ensure compatibility. For example, with NDK R27, you should add WLZ, max page size equals 16,384 during linking. Even older toolchains require an additional common page size equals 16,384 argument. Keeping your toolchain up to date is the easiest way to avoid headaches. One of the biggest risks comes from hard-coded constants in your code. Many C and C++ libraries define as 4096, assuming a 4 KB page. This needs to change. Instead, use runtime queries like sysconf sc page size in C or OS, sysconf os constant, sc page size in Java. This way, your code adapts dynamically to whatever page size the system enforces, whether it's 4 KB, 16 KB, or something even larger in the future. Making this change now will save you from future compatibility headaches. Testing is just as important as updating your code. Android Studio now provides emulator images configured for 16 KB pages, so you can validate your app's behavior without needing physical hardware. On supported devices like recent Pixel phones, you can check the page size directly with a DB shell getconf page size. Samsung has also integrated 16 KB testing into its remote test lab, giving developers even more options to ensure their apps are compliant before release. Don't forget about your third-party dependencies. Many developers rely on precompiled SDKs for analytics, voice chat, or video streaming, and these libraries may not yet support 16 KB pages. Unity has confirmed that its Vivox SDK is compliant, but other vendors may still be catching up. Identifying and updating these dependencies is a key part of the adaptation process. Make sure to check with your vendors and update any libraries that aren't ready for the new page size. You might wonder why all this matters to end users. The answer is simple: performance and battery life. Faster app launches, quicker camera startups, and longer battery life all add up to a better user experience. Even small improvements, when multiplied across billions of devices, can make a huge difference. Users may not see the technical details, but they'll definitely notice when their favorite apps feel faster and more responsive. First glance, this transition might seem like a hassle for developers. Rebuilding, retesting, and auditing dependencies takes time and effort, but it's important to remember that this is a forward-looking shift. The 4 KB page size is a relic of older hardware constraints. By moving to 16 KB, Android aligns itself with modern ARM64 platforms and prepares for even larger page sizes in the future. This change is about future-proofing your apps and the entire ecosystem. One of the most important lessons from this transition is the need for page size agnosticism. Instead of assuming the environment will always be the same, developers must write code that queries and adapts to the system's page size. This not only prepares your app for the current 16 KB world, but also makes it resilient to future changes, like a possible jump to 64 KB pages down the line. Embracing this mindset now will save you trouble later. Move to 16 KB pages starts deep in the Android kernel. While it might seem like a minor technicality, changes at this level ripple up through the entire stack. From memory management to app performance, even small tweaks in the kernel can have a big impact on how software behaves. That's why Google is making this change mandatory for all new apps and updates targeting Android 15 and above. Let's look at the numbers again. Google's benchmark showed that apps launched up to 30% faster in some cases. Camera startup improved by as much as 6% and system boot times dropped by nearly a second. Battery life also saw a 5% reduction in power draw during app launches. These improvements might seem small, but they're significant when you consider the scale of the Android ecosystem. November 1, 2025 deadline isn't just a suggestion, it's a hard requirement. If your app isn't compatible with 16 KB pages, you won't be able to publish updates on Google Play. This makes compliance a top priority for any developer targeting Android 15 or higher. Start testing and updating your code now to avoid last-minute surprises. If you haven't updated your build toolchain in a while, now is the time. Modern versions of the Android NDK handle 16 KB pages by default, but older versions require manual configuration. Check your build scripts and make sure you're using the latest tools. This simple step can save you a lot of trouble down the road. Instead of hard-coding page sizes, use runtime queries to determine the system's page size. In C, use sysconf sc page size. In Java, use os sysconf os constants sc page size. This approach ensures your code adapts to whatever page size the device uses, making your app more robust and future-proof. Android Studio now offers emulator images configured for 16 KB pages. This means you can test your app's compatibility without needing a physical device. Make sure to run your app on these emulators and check for any issues related to memory management or performance. Early testing helps catch problems before they reach users. For those with access to recent Pixel devices or Samsung's Remote Test Lab, you can test your app on real hardware configured for 16 KB pages. Use a DB shell getconf to verify the page size on your device. Testing on actual hardware provides an extra layer of confidence before releasing your app to users. Some third-party SDKs are already prepared for the 16 KB page size. For example, Unity's Vivox SDK is compliant. However, not all vendors have caught up. Check with your SDK providers and ensure you're using the latest versions. If a library isn't ready, reach out to the vendor or look for alternatives. Take time to audit all your project's dependencies. This includes analytics, voice, video, and machine learning SDKs. Some libraries may lag in supporting 16 KB pages. Make a list of all third-party components and verify their compatibility. Updating or replacing non-compliant libraries is essential for Play Store approval. If you use continuous integration and deployment (CI/CD) pipelines, make sure they're set up to build and test for 16 KB page size compatibility. Update your build scripts, test configurations, and emulator images to reflect the new requirements. Automated testing is your best defense against unexpected issues. Game engines like Unity and Unreal, as well as other native libraries, often interact directly with memory. If you're building games or high-performance apps, double-check that your engine and all native plugins are compatible with 16 KB pages. This is especially important for custom builds or older versions. Apps that use machine learning, voice, or video SDKs often rely on native code. These libraries must be audited for 16 KB page size support. If you use popular SDKs, check their documentation or contact the vendor for updates. Ensuring compatibility here is critical for app stability and Play Store compliance. Older codebases are more likely to have hard-coded assumptions about page size. If you maintain legacy apps, review all memory management code and update any constants or logic that assume a 4 KB page. Refactoring now will save you from future bugs and Play Store rejections. Google provides official documentation and blog posts detailing the 16 KB page size transition. These resources cover everything from technical breakdowns and build configuration to testing methods and compliance deadlines. Make use of these guides to ensure your app is ready for the new requirements. Developer community is actively discussing the 16 KB page size shift. Forums like Reddit's r/AndroidDev are full of real-world experiences, tips, and concerns, especially around third-party SDKs like FFmpeg. Engaging with the community can help you spot potential issues early and learn from others' solutions. Samsung's Remote Test Lab now supports testing for 16 KB page size compatibility. Developers can access compliant devices remotely and validate their apps in a real-world environment. This is especially useful if you don't have access to the latest hardware but want to ensure your app is ready for the new standard. Google's developer tools, including Android Studio and the Android emulator, are updated to support 16 KB page size testing. Make sure you're using the latest versions to take advantage of these features. Regularly updating your tools ensures you're always ready for new platform requirements. Move to 16 KB pages is just one step in Android's evolution. By making your code page size agnostic now, you're preparing for whatever comes next, whether it's 32 KB, 64 KB, or beyond. Future-proofing your app is an investment that pays off as the platform continues to evolve. 16 KB page size requirement affects not just your code but your entire build pipeline. Update your build scripts, CI/CD configurations, and testing environments to ensure everything is aligned with the new standard. Consistency across your pipeline reduces the risk of last-minute surprises. Android's memory management is evolving to keep pace with modern hardware. Larger page sizes mean fewer pages to manage, smaller page tables, and fewer TLB misses. This reduces the time the CPU spends shuffling memory mappings, leading to better overall performance and efficiency. One of the most user-visible benefits of the 16 KB page size is improved battery life. By reducing the CPU's workload during app launches and other memory-intensive tasks, devices draw less power. This means your phone lasts longer on a single charge, a win for everyone. Users love fast apps, and the 16 KB page size helps deliver just that. With fewer pages to manage, the system can launch apps more quickly. Even a few percentage points of improvement can make a big difference in how users perceive your app's speed and responsiveness. The improvements aren't limited to app launches. Camera startup times are faster and system boot times are shorter. These enhancements contribute to a smoother, more enjoyable experience every time you use your device. Failing to adapt to the 16 KB page size requirement means your app updates could be blocked from the Play Store. Don't let a technical oversight keep your app from reaching users. Start the adaptation process now to ensure your app remains available and competitive. To recap, here's what you need to do. Update your toolchain, replace hard-coded page size constants, test on 16 KB emulators and devices, audit all dependencies, and monitor vendor SDK readiness. Following these steps will ensure your app is ready for Android's new memory management era. While the transition requires effort, it also brings benefits. Developers who adapt early will enjoy smoother app performance, fewer support issues, and a future-proof codebase. Embracing change now positions your app for long-term success on Android. For users, the 16 KB page size means faster, more responsive apps, quicker camera launches, and longer battery life. These improvements enhance the overall experience, making Android devices more enjoyable and efficient to use every day. Android's move to 16 KB pages is just one example of how platform changes can ripple through the entire development ecosystem. Staying informed and proactive is the best way to ensure your apps remain competitive and deliver the best possible experience to users. For more details, check out Google's official documentation and blog posts on the 16 KB page size transition. These resources provide in-depth technical guidance, code snippets, and testing strategies to help you navigate the change smoothly. Don't hesitate to reach out to the developer community for support. Forums, blogs, and discussion groups are full of insights and solutions from others who are navigating the same transition. Sharing knowledge helps everyone succeed. The best way to handle platform changes is to stay proactive. Monitor official announcements, update your tools regularly, and test your apps thoroughly. Being prepared means you can adapt quickly and keep your apps running smoothly no matter what changes come next. Android's migration to a 16 KB page size is more than a technical detail. It's a platform-wide performance upgrade, a compliance deadline, and a call for developers to modernize their memory handling practices. By acting now, you ensure your app is ready for the next generation of Android devices and deliver the best possible experience to your users. Even details buried deep in the OS architecture eventually shape the way software is built and shipped. Paying attention early not only avoids disruption but also positions your app for long-term success. Embrace the change, update your code, and get ready for a faster, more efficient Android ecosystem.